Hey coders! Welcome to my YouTube channel. Ready to build something awesome? This is the FireFlow Fitness Analyzer, a super cool dashboard that uses AI to predict your calorie burn. Let's check it out and see why you gotta code this. Look at this. FireFlow's your AI fitness coach. On the side, drag sliders to add your info. I'm 25, 175 centimeters tall, 70 kilograms. Working out for 45 minutes with a 120 heart rate at 37.2 degrees temperature. Hit Analyze Metabolism and boom progress bar and balloons. Now Coaching Insights gives tips. Keep your heart rate at 72 to 96 beats per minute. Drink 150 milliliters of water every 10 minutes. Rest 24 hours active or 48 hours full. System Diagnostics says the AI's gradient boosting v2.3 last trained May 25, 2025 at 3:16 p.m. using 15,000 data points. Check live metrics. I burned 226 calories. That's like eating half a cupcake. The 4.5 gram fat equivalent means those calories melted some fat. Cardiac load shows my 120 beats per minute heart rate, and thermal output says 37.2 degrees Celsius with a 20% metabolic flux. That's how much my body's energy is revving up compared to a normal 37 degrees Celsius, like a turbo boost. Now, visualization mode is on fire. In CyberGym, a 3D graph shows your 226 calorie burn as a wavy surface. Higher means more calories. The blue line tracks heart rate and body temperature, glowing as you sweat. Spin it to check your workout's vibe. In BioLab, live cardiac rhythm graphs your heart rate pulsing, showing how hard your heart's working. Body thermal imaging is a heat map. Brighter spots mean warmer body parts. Energy matrix is a dial showing 227 calories with a negative 74 delta, meaning you burned 74 calories less than a 300-calorie benchmark. Maybe a chill workout, or you're super fit. Model insights? The AI's crazy accurate. Mean absolute error is 1.5 kilocalories, so predictions are off by just 1.5 calories on average. R squared is 1. Perfect fit. Likely simplified data for this demo. The pie chart shows 93% of your burn comes from workout duration, 4% from heart rate, and other factors are tiny. How do we make this? Don't worry, I've split it into two easy parts for beginners. Part 1. We'll train the AI model in Google Colab. It's like teaching it to predict calories. Part 2. We'll build this awesome dashboard to make it look cool. It's simple, and you'll have fun. Open Google Colab, and let's get coding. You'll love it. First of all, we need to upload the dataset. We have two files, exercise.csv and calories.csv. To upload them, look at the left sidebar. See that folder icon? Click it, then click Upload. Find files. You can download them from my tutorial link in the description. Select both, hit Open, and they'll appear in Colab's files. Easy, right? This data is our workout gold. These have workout details like age, weight, heart rate, and calories burned. Now I'm getting started with the coding part by importing all the libraries the AI needs. I created a new code cell and started with pandas to read CSV files and turn the data into organized tables. Then I imported NumPy, which helps with numerical calculations, things like BMI and other math-related stuff. After that, I brought in matplotlib.plot. Matplotlib is great for basic plots, and Seaborn for visualizations. And Seaborn adds more style and color to the charts. I also added the tools to split the dataset with train test split, which helps divide the data into training and testing sets. Finally, I imported mean absolute error, an R2 score, so I can measure how well the AI models perform. I ran the cell and didn't get any errors, so everything's set up and ready to go. Let's load our data. In a new cell, I start by reading in the exercise data with exercise equals pd.read CSV and giving it the file path. Then, I do the same for the calorie data with calories equals pd.read CSV and its file path. This loads both files into pandas tables. After that, I merge the two datasets with df equals exercise dot merge calories comma on equals user ID, basically matching up the two files using user ID, like piecing together a puzzle. Next, I start pre-processing the data. I convert the gender values into numerical form, where male becomes 0 and female becomes 1, so the AI can understand it. Then, I calculate BMI, using the formula where weight is divided by height squared in meters. Once that's done, I select the features. These are the variables that will help predict the number of calories burned. The target variable, or what we're trying to predict, is the calories burned. Finally, I split the data into training and testing sets. 80% of the data is used to train the AI, and 20% is used for testing, kind of like studying for a test and then taking it. Now, I'll run this step and check that everything works smoothly. To better understand our data, let's create some cool visualizations. First, in a new cell, use a pair plot to see how important features like age, weight, duration, heart rate, and calories relate to each other. This will show scatter plots comparing each feature side by side. Add a title above the pair plot that says Feature Relationships, so it's easy to follow. Run the cell and look at those dots. You'll notice patterns, like how longer exercise duration usually means more calories burned. It's a great way to spot trends at a glance. Next, in another new cell, Let's create a heat map to see the correlations between the numeric features in the dataset. Set the plot size so everything fits nicely. Then generate the heat map with colors showing how strongly each feature is connected to the others. Use a color scheme where red means strong correlation and blue means weak correlation. Look closely. Duration and heart rate show big numbers, which tells us they are really important for predicting calories burned. Time for the exciting part, training our models. We're using three algorithms: linear regression, which predicts with a straight line; random forest, which uses lots of decision trees; and XGBoost, a super fast, smart tree model. In a new cell, import these three. Then create a dictionary of these models: linear regression, random forest, and XGBoost. This sets up our three models. Now, train them. First, initialize the variable results. The for loop is used because we have three models. This trains each model, predicts on test data, and saves scores. Run it. No output yet, but our AI's learning. Let's see how our models did. In a new cell, I'm creating a table to compare how each model is performing using two key metrics: mean absolute error and R-squared score. MAE shows how far off the predictions are on average. The lower it is, the better. R-squared tells me how well the model explains the variation in calorie values. The closer to 1, the better. After setting up the table, I'm plotting two bar charts side by side, one for MAE and one for R-squared. These visuals make it easy to compare the models. As you can see, models like Random Forest and XGBoost stand out with lower MAE and higher R2, meaning they're making more accurate predictions and doing a better job overall. Now I'm checking how the actual calorie values compare to the predicted ones by plotting them in a scatter plot. Each dot shows a prediction from one of the models, with actual values on the x-axis and predicted values on the y-axis. I added a dashed diagonal line to represent perfect predictions. Dots that land close to that line mean the model got it right. Looking at the plot, XGBoost had the best performance overall. Its dots are clustered tightly around the line, which means its predictions were super accurate. Random Forest also did well, with most of its points close to the line too, just not as tight as XGBoost. On the other hand, Linear Regression had a lot of points spread far from the line, which shows it struggled more with accuracy compared to the other two. Now I'm checking what features drive calorie burn by looking at feature importance for the tree-based models. I'm plotting two bar charts side by side, one for Random Forest and one for XGBoost. These charts show how much each input feature, like duration, heart rate, etc., contributes to the model's predictions. In both plots, duration stands out by far. It accounts for around 93% of the importance in XGBoost, which means the amount of time spent working out is the biggest factor in predicting calories burned. Heart rate also contributes a bit, around 4%, and the rest have very minimal impact. So overall, both models are telling me the same thing. If you want to predict calories burned accurately, Duration is by far the most important variable, followed by heart rate. We've trained our model, now it's time to see it in action. In a new Colab cell, let's add some sliders to input values and make predictions. It's super fun and interactive. Start by adding sliders with the comment, #TitleFire, predict calories burned. Then, create sliders for the following inputs. Gender, drop-down male or female. Age, default 30. Height in centimeters. Default, 175. Weight in kilograms. Default, 70. Duration in minutes. Default, 45. Heart rate. Default, 120 beats per minute. Body temperature. Default, 140 degrees Fahrenheit, 37.2 degrees Celsius. Try moving the sliders to see how changes in age, weight, or heart rate affect the results. It's a great way to explore how your model reacts to different inputs. Next, wrap all those inputs into a data frame. Use the correct column names: gender, age, height, weight, duration, heart rate, body temp. Remember to convert gender from text to numbers. Male becomes 0, and female becomes 1. Then calculate BMI by dividing weight by height squared, in meters. Add that to your data frame as a new column. Now it's prediction time. Store each prediction in a new dictionary called predictions. Loop through your trained models, stored in a dictionary called results, and predict the number of calories burned for each one. Print out the results using a loop, something like prediction results. Then display each model and how many calories it predicted, nicely formatted to one decimal place. Finally, let's make it look awesome. Plot the predictions using a horizontal bar chart. Label the x-axis as calories and give it a title like Model Predictions Comparison. That's part 1, Coders. We built the AI brain for Fireflow in Colab, trained 3 models, compared them, and made predictions. Random Forest or XGBoost is our winner for part 2, where we'll build a dashboard to show these predictions with 3D graphs and more. This project is perfect for beginners, easy, fun, and looks amazing in your portfolio. Open Colab, try this code, and play with those sliders. Like, subscribe, and comment Fireflow to catch part 2. Let's code, let's burn.